Okay, let's see. Let's do this. First off, we'll just delete everything in this bottom row here and start all over again. Awesome. So for now we keep the drums. It's a nice rhythmic backbone. And we'll create a bass line and a melody for these drums. And today we're going to do something very special. I have this timer here. And I'll allow myself 20 minutes for each patch to keep track of the time a little and to condense the information a bit. Alright, let's go. An amplifier, AD envelope. Let's see what else would be nice. Of course. Oscillator. Awesome. We will need some means to synthesize a melody later on. Let's go with this and a sample and hold. There we go. Awesome. Feeling very much West Coasty today. So let's move the filter aside. Let's craft something from the ground up, rather. Choose very simple waveforms with very little frequency content. Let's choose something between a sine wave and a triangle for this oscillator. And this oscillator will be routed through this amplifier. And finally, through zero, frequency modulate the second oscillator. And we will do that dynamically according to this AD envelope that is clocked. Okay, for now we will clock it with this 8th counter. We will also use this for the melody. Okay, here I make use of the combined output of the microsine LFO. Basically, the combined output is a combination of all of the 3 individual sine waves. And with this, I can get a pretty complex modulation signal in a very, very efficient form factor here. I will desync it so it is free running, and I will re-trigger it according to some clock, and this is 4/1. So for 4 bars, it will randomly output, or not randomly, it will output this sine combination. And I will sample that for a melody. Then I will quantize that. Let's go with F minor. Then feed that in here. And since the beat is getting boring a bit, let's just quickly connect it here so we can listen to that. Okay. I should combine should actually patch the sample and hold output and not the sample and hold trigger output. so that we can actually hear the melody. That would be great. Okay, now the pitch is all over the place. Because these sine LFOs, they're in the range between -5 and +5 volt. And 1 volt is 1 octave. So we're going between -5 octave to +5. That's LFO territory to very high. And all we need to do is attenuate it. Let's say we will go to 0.2. That makes it 2 octaves up and down. And we will offset it a little by, let's say, 1 volt. Oh, let's not offset, make a baseline first. Okay, now it sounds very random because we allow a lot of notes, basically all of the notes in the scale of F minor. Let's just turn off some notes. Okay, awesome. Now let's craft our West Coast bass a little more. See if it helps if we choose a different waveform. Let's blend between triangle and sine wave here, and that's already a little bit more interesting. I have introduced another oscillator. That would be a modulator for our modulator. Of course, we need to connect the pitch input so that it stays in pitch with the other oscillators. And we will add this oscillator into the linear FM input of our modulator. So the modulator is modulating the modulators. I heard you like modulators. Okay, let's see. Choose a different octave here. Okay, that's cool and all. Let's make that a little bit more dynamic by patching our envelope and opening the attenuator. Okay, that's giving us a decent baseline, but I want it a bit more stabby. So I have a few options. I can either modulate or change the envelope of our modulators, which change the timbre of the overall sound. Like if I pull back the decay, or give more decay. Or I can change our second envelope, which shapes the volume or the amplitude of our actual carrier oscillator that outputs the sound. Okay, that's cool. We will combine both. And now we have several options. We can either play with the decay, open it up, close it down a little, or we can use the shape knob. If I pull it to the left, the decay phase gets sharper. It's more exponential. If I pull it to the right, it gets more logarithmic. Okay, that sounds decent. Let's do the same for our output volume. Okay, awesome. That's our West Coast baseline. I kind of want to make some more things with the hi-hat pattern because it gets a little stale. So what we're doing now is we're adding a second step sequencer and a multiplexer to switch between these two step sequences. So I take this output to the hi-hat and patch it in the multiplexer, and now I patch every second input of the multiplexer with the first step sequencer, and every second input with the second sequencer. I will add retrigger. Let's put the counter to 8 because we have 8 steps, and now let's trigger it. Now these two sequences are out of sync, so we need to sync them once, and then they will stay in sync. You do that by re-triggering them via this input, and the easiest way is to use a button. I oftentimes wire a button output to all of the re-trigger inputs of everything that I need to re-trigger. Typically sequencers like the step sequencer, the CV sequencer, the clock. Pushed something. What did I do? Okay, I accidentally moved the delay. And actually, I will need to connect this to the sine LFO here as well, so that if I push this button, the sine LFO will re-trigger and restart with the whole sequence. Okay, that's awesome. We have 10 minutes left to create a nice melody for this bass line. Sounds a little happy. That's great. And we will do that by using the second channel of the sample and hold. Let's separate these a little. Let's use a counter to create an interesting sequence here. Okay. I have this 8th note pulse from the clock, and I will patch that into the counter here. Sorry, I had to zoom a little. Patch the counter re-trigger into the button, and let's put the re-trigger into our slower clock as well, so that it is 4/1. So after 4 bars, this counter will reset. Now what we can do is we can choose interesting count measures. So now every 3rd trigger input, this will output a trigger. Let's say every 3rd, every 5th. It's always good to choose prime numbers here, so the sequence does not repeat too quickly. 4 and every 8, that is okay. Okay, now we need the actual melody, and we will use 2 oscillators, an AD envelope and an amplifier again. We need to connect our melody output from the sample and hold to a quantizer, and the quantizer to both oscillators. Let's quickly patch the AD envelope to the amplifier. And now the first oscillator, this will be an FM patch again, will be our modulator, and the second will be the carrier. So by feeding the modulator oscillator through the amplifier, we have control over the strength of the modulation. Let's use phase modulation this time, so patch it into the PM input, and our carrier goes out into the second channel of the amplifier and into another channel in the mixer. Let's turn it down a little. Okay, so our AD envelope needs to receive triggers and needs to receive the same triggers as our sample and hold that's sampling the melody. And that are the triggers from the counter. And if I turn up this attenuator now, hear the melody. Oh yeah, I forgot to connect the attenuator here too. In that case, I'm connecting 2 channels of the sine LFO instead of the combined output, just to have a different modulation signal. I have to be careful here now, because both of these output will output signals from -5 to +5 volt. So I need to adjust the attenuator accordingly and turn it down a little bit more than the attenuator here at the top, which received the common output of the sine LFO that is scaled for all 3 sine outputs, so it is still in the range of -5 to +5 volt. Okay, we can even use this offset to get the melody in a higher register. See if we can choose a different waveform. Since we now set it to square wave, we can even apply pulse width modulation. We choose the 3rd channel of our attenuator here and choose the 3rd LFO, because that is the one that is the slowest. And we instantly got some movement in our melody line. We can try some interesting frequency ratios by detuning the fine knob. Okay, that sounds decent. You can use another attenuator for this oscillator to create some feedback phase modulation. Basically go from the output through an attenuator into the phase modulation input of the same oscillator. And if we now turn up careful here, because this gets noisy very quickly. There can be some very interesting timbres in there. You can experiment with positive feedback by turning the attenuator to the positive side, or with negative feedback by turning it in the opposite direction. That sounds nice and crunchy. Okay, that is interesting. Sounds a little bit dissonant, but I like it. It's a bit overwhelming in the mix, so let's turn it down in the mixer up here. Okay, it sounds too static. It's just repeating and that's boring. So let's introduce a delay. We have 2 minutes left on the clock. Wow, time is flying by. Actually, let's use a very short delay here. sine LFOs from back here in this attenuated channel to modulate the delay time. And while that is very interesting, let's turn down the attenuator very much, so that is almost 0, to create a makeshift chorus here. Okay, and since we sacrificed this delay to create a chorus, let's create another delay. Let's turn down the resonances a bit. Okay, time's up, and I think we're done with the patch for now. Let's save it and move on. Okay, let's remove the low pass filter and save it again. Alright, so before we delete everything and go to the next patch, let's quickly glance over this once more. We have our drum track that's pretty standard. The only thing that's a little bit different here is that we have 2 step sequencers that are multiplexed to create an alternating pattern for our hi-hats. Maybe what's also interesting about the hi-hats is that the level of the hi-hat is controlled by an LFO to create some more rhythmic interest for the hi-hat. Quickly have a listen here. It's very subtle, but that really helps to push the idea of the rhythm. Can choose a different rhythm maybe. See how that works with the drums. That's cool as well. Bass line back. Okay, I like that. Sounds interesting. But that's it for the drums. Let's see about our bassline melody. But before we talk about the actual sound generation, talk a little bit here about the melody generation. It's randomly sampled from the sine LFO. Here is our sample and hold, and the bass line is just the 8th note pulse. So every 8th note the input signal is sampled, and this value is then kept until the next pulse is received here. The held signal is then quantized with this quantizer and output to all of the oscillators in the bassline. What makes this melody special is that this sine LFO has the combine output, which is a combination of all 3 sine LFOs, and since they all move in different speeds, we get a pretty complex pattern, or a pretty complex control voltage for the sample and hold to sample and quantize into pitches for the oscillators. When we take this output raw, we get a signal from -5 to +5 volts, and that's a 10 octave range, which is quite a bit much. So we take this attenuator and scale it down by a factor of 0.2. So now we have, instead of 10 octaves, we have 2 octaves up and down, which is more suitable for the bass line. We do the same for the accompanying melody line, that's also playing here, but we take 2 LFOs, 2 individual LFO output instead of the combined output, and here we have to be extra cautious because these two outputs will output voltages from -5 to +5 volts individually. So in combination we have a signal here from -10 to +10 volts. We need to adjust the attenuator accordingly and turn it down a lot more. And this signal is then also fed into our sample and hold. And in this case we did not use a clock directly to sample the modulation. We use this counter module here that is clocked by the 8th pulse counter and outputs triggers according to these count values. So the trigger input pulses are counted, and for every 3 counts a trigger is output here, for every 5 counts here, and accordingly. Again, at the bottom we have a combined output that combines all of these counters into one trigger stream, and by doing it like this we get a pretty complex pattern out of these 4 counters. It's basically modular sequencing. This melody is quantized by another quantizer and then fed into the 2 oscillators that make the melody line. The counter output also is fed into the AD envelope that takes care of shaping the amplitude curve of the modulation and the carrier modulator and the carrier oscillator. Okay, the 2 sound generators are pretty standard. We have here 2 West Coast style patches. The baseline is 2 modulator oscillators, where one modulator is modulating the other modulator, which is then in turn modulating the carrier oscillator that is outputting the sound. Both of these modulators are fed through an amplifier and are then shaped further by the AD envelope here, the first channel of the AD envelope, to get some dynamics to the timbre. So without this modulation, it's pretty boring because the sound is constant, but by applying an envelope to the modulators we get a time varying modulation. And we do the same with the carrier oscillator with this amplifier. Again, would be pretty boring without. It's just constant drone. Well, in that case not a constant drone because the sound is shaped by the modulators, but still the actual output is constant. For the melody we basically do the same. We have 2 oscillators here. Interesting thing is that the modulator is outputting a signal into an attenuator, which in turn gets fed back into the phase modulation input of the modulator itself. So this is feedback phase modulation. And the modulator oscillator is also detuned quite a fair bit to get this dissonant tone. And again, the output is shaped by an amplifier in an AD envelope before finally being fed into the phase modulation input of the carrier oscillator, which is also shaped by an amplifier and an AD envelope. And then we use a delay with a very short delay time and a much attenuated sine wave from our sines LFO here at the beginning. And this is really almost 0 modulation here to get this makeshift chorus. And from here we go into this delay for some more interesting rhythmic, like without the delay and with the delay. Just adds more rhythmic complexity and more interest to the sound. I like using delays. Okay, that's it. Let's save it one last time because I don't know what I changed. And let's get rid of everything again. Okay, we will stay in the DnB genre, but we will mix things up. Okay, that's more interesting. And of course, we need another baseline. So let's get our oscillators going. One oscillator, two oscillator. Also, let's pull in a noise source. Maybe we will need that later on. Let's see. We get an amplifier. I used AD envelope a lot. I like it. It's my favorite envelope. AD is my favorite envelope type. Just so percussive, and you can do so much with it. But maybe it's time to use another envelope as well. We have this awesome envelope generator. And fun fact, because I love AD envelopes so much, you can disable a sustain phase, link the release to the decay, and guess what? You have an attack decay envelope again. But this time it's a single channel. So with this ADE you have two channels, which can be interesting to combine these two envelopes. But with this envelope in AD mode, you have control, CV control over the attack and decay time, so that can be interesting as well. Yeah, let's remove this AD envelope and use that envelope in AD mode instead. Okay, what else can we do? We have an amplifier, we have two oscillators. Let's create a respace. Stable in drum and bass. Let's connect this amplifier output here. Okay, this is the pure saw. Oh, a mix between saw and square sounds nice here. Let's do the same here. Or let's not. Let's do some West Coast res, and I forgot to start the timer. Good. 20 minutes, next patch, minus the 2-3 minutes I wasted on this new drum pattern and this stuff, but that's okay. Let's use a simple waveform here, sine wave. Let's use an amplifier. I wanted to go for an attenuator, but oh, sorry, my bad. Okay. This oscillator into this amplifier output into the phase modulation input here. And we now turn it up, we get a pretty gnarly sound, but it's not resync. The key to a respace is the pitch detune. We detune our modulator. Then we get the characteristic moving sound. Oh, that sounds nasty. I want to keep this. We will mix the coasts a little, because this is a bit too much for a static tone, so let's filter it down. For our trusty low pass filter. And since we have such a gnarly tone, let's go into neurofunk territory. Create an interesting bass line out of this. We'll use sine LFO and an attenuator to modulate the cutoff frequency of this filter. We'll use the combined output of the sine LFO, which is a combination of all three LFOs. We will unsync it so these are free running. Now let's get some random frequencies, maybe even put them out of phase. Okay, that's great. We will patch a slow clock into the sine LFO to reset it so we can get a pattern going. Okay, that's a pretty boring pattern so far. We need to get some more action going in here. Let's take our 8th pulse into this gate input. That's a lot better. We'll also take this pulse okay, that is a moving baseline. Okay, let's add another filter, add more interest to this. Okay, let's take another sine LFO, detune the phases, randomize our speeds a little. We will again use the envelope output, but this time in the linear FM input of the filter. The difference is the exponential CV for the filter cutoff is actually 1 volt per octave, so you can put pitch signals in there and it will track the pitch. It will go out of tune with heavy resonance and heavy drive, but it is pretty stable. Linear FM, or the linear cutoff CV in that case, will offset the cutoff frequency linearly. So it will not follow the pitch scale. It will just, if you offset it 10 Hz, it'll be 10 Hz. That's awesome. Let's turn down the hi-hat a little. Okay, I have 30 minutes left and I don't know how to proceed. Maybe we need some atmosphere instead of a melody, because that bass line is very busy already. And I'm afraid if I add a melody it will get too overwhelming. Let's stay in the style of West Coast and add the feedback folder. And another oscillator. Also let's play with the diffusion module and let's get a delay in here. See what fun things can we pull. We have the noise that we did not use for the bass line. Oh yeah, let's choose peaking equalizer. Peak EQ. The equalizer part is actually a bit misleading because obviously you can use it for equalization tasks, but the fun is if you turn up the gain to 24 decibels and sweep the frequency and then go into some kind of distortion saturation, because these frequencies will get blown up. That's very nice for sound design in my opinion, but we will see about that. Okay, West Coast D, we will choose a low harmonic count waveform, like sine wave or triangle wave. Let's go into our peak. And from here, let's go into the feedback folder, into the diffuser, into the delay, and into our output mixer. And let's turn down everything. Oh, I like that already. Let's get another sine LFO going. That is gonna be reset by this clock here, and that will be 8/1. Because this is an atmosphere, it can have a longer bar, longer count until it repeats. Okay, we'll need an attenuator, of course. We can scale the signals. And let's apply that to the waveform. We have a comment from Braveheart's Bird Studios. Hi, welcome to the stream. Hope you enjoy. These micromodules are a cool idea to get more happening in a small space. Yes, indeed. That was the main idea behind these modules. Awesome that you noticed. Oftentimes when I do patches, I find myself needing some small utility or just one function. It basically started with sequencers, not the step sequencer, but the CV sequencer. I oftentimes sequence modulation with CV sequencers, and it just feels wrong to pull in like a huge 8-step sequencer that takes up half your screen just to apply some modulation to, let's say, frequency of a filter. And these small modules are just perfect for the task. Pull that in, it does not take up much space. If you put it next to a big module, it looks like it's attached to that module, like it belongs there already. And you get so much functionality in that small space. Like, let's actually talk about the CV sequencer real quick. Because we will also use that now. It's 8 steps of CV that you can freely choose from -5 to +5 volts, but you can also limit the range to 2 volt range from plus to -1 to +1 volt. So you have finer control over these steps. So you go from a 10 octave range to a 2 octave range, which can be more sensible for pitch CV or for smaller modulation. And you also have the quantized modes, so it is quantized to semitones in the plus to -5 volt range or in the plus to -1 volt range. So you get already a lot of control over the pitches or the CV you can set. And in essence, these modules are designed for interoperability. So you have 8-step sequencer here, but you can easily turn that into a 16-step sequencer if you use this multiplexer module and you feed the output in every second step input and the second sequencer and every second input of the multiplexer. And then you have an alternating sequence between these two sequencers, which you can of course tune individually. And you can continue with that indefinitely. So now we have 16 steps, but there's nothing stopping us from getting 32 steps, 64 steps, or some other weird measure. And you can even mix and match. Nobody forces you to use the second and the second only. Say you have want to combine interesting sequences. And you can also get polyrhythms going pretty easily with this retrigger input. When you have a trigger and you can use the counter that we already used before. So let's say I want a polymeter with only 3 nodes that keep repeating. So use this counter, use the same trigger input, and output this counter into the retrigger input, and then I only get this first 3 steps that keep repeating now. So there's a lot in this small form factor to discover. The main design goal was to have these small modules that are easy to use, very approachable for beginners, but they offer a lot of depth and expansive functionality for seasoned patchers and for everybody who wants to dive in deeper. The Erica Picosynth, yeah, that was indeed an inspiration. These small form factor Eurorack modules, like the Pico system from Erica Synth, or the 2HP module range from 2HP Modular. Yeah, those are great modules. And now you can have the same form factor in Voltage Modular. Okay, but enough of the talking. We only have 5 minutes left to finish this patch. Let's get the atmosphere going. I think we'll use a very slow sequence here. Let's actually keep this. We have this counter that's 4/1. That's a 16th counter. Whoops. 8th counter. Let's use the 8th counter here. And we can, and we will. No, we don't need this trigger input. In fact, we will scale that 8th counter down. We have patched it into this counter module. And if I now say count up to 8, then it's 8/8, that will be 1 bar. Let's make that a polymeter, 12/8. That's like a dotted bar. And then we use this counter to trigger this counter module and this CV sequencer. So this CV sequencer will now move very slowly with 1 dotted, and after 3 steps, if we actually connected it, it will reset. Yes, reset. 1, 2, 3, and reset. Awesome. Choose some notes by random here. Let's introduce some resonances. Hi, work. Welcome to the stream. What's up? For everybody just joining, we're finishing our second or third drum and bass patch. Today is drum and bass patch day. I decided And I have this timer set up, which only allows me 20 minutes for each patch. And the timer is already counted down to only 2 minutes left. So we better get going. And finish this patch. Let's see, we have a screaming filter here that we will use to filter away all of the lower frequencies with this high pass input. Let's say input mixing filter, so depending on which input you use, you get a high pass, band pass, or low pass response. And if you actually patch all of 3, you get an all pass response, which can also be very interesting. I kind of like the low pass, but that will not work well with the baseline we already have. Okay, let's modulate the size of the diffuser. Okay, that's awesome. Let's add some noise. Where do we input the noise? Let's add some noise via phase modulation. Filter the noise down. Okay, that could be interesting. Let's use, I don't know, this sine LFO. Very slowly. To add some occasional noise. Okay, time is up. Let's combine the atmosphere with the bass line again. And the drums. Okay, it's not the greatest patch, but it works. So let's save it, and then we will go over this patch, discuss what we have done and why we have done that, and move on. Okay, let's go. Drums first. Pretty basic. Step sequencer, kick module, step sequencer, snare module. Here we sequence the kick triggers and the snare triggers of these step sequencers. Pretty standard. I chose a very broken two-step pattern because it's 160 BPM drum and bass. We need some breakbeat in here. We have a hi-hat module that is sequenced by two-step sequences that are multiplexed together in an alternating fashion. So basically this is a 16-step pattern. We have this LFO that is controlling the level of the hi-hat a fair bit to get some more interesting rhythmic movement in the hi-hat. So it's not a static, like if we remove it, it's just a very boring beat. But if we add the LFO, it gets us this nice up and down movement of the amplitude of the hi-hat, which really adds to the rhythm. Yeah, this all feeds into our mixer, output mixer that takes care of clipping the output so we get no surprises here. Could even activate the DC blocker, but I don't think we need that here. Then we have two West Coast inspired sound generators. We have this bass line that is a somewhat neurofunk bass line. We used two oscillators. One oscillator is detuned and is then fed into the phase modulation input of the second oscillator. So again, we have a carrier and a modulator. Modulator is detuned to get this nice wobble effect that you know from Reese baselines. These two oscillators are then, or this carrier oscillator signal is then fed through a filter, which is heavily modulated by some sine LFOs that are attenuated. And for the rhythmic pulse, we have this envelope module here that is set to AD envelope mode. That gives us this pulsing, so we have some rhythm to catch onto, which is also modulating these filters. And this filter is then fed into the second filter, which also gets modulated heavily by the sine LFOs and the envelope pulse. This nasty bassline is accompanied by an atmosphere that is generated with an oscillator, some noise, the peak EQ module that accentuates frequencies in the upper frequency spectrum, kind of pulls that out to add some interesting resonances. To get some more harmonics going, we have this feedback folder, which is a wave folder that feeds its output back into the input to generate some interesting tones. Like if you turn up this timbre, some interesting noises. That is fed into the diffuser, which is basically half of a reverb that washes out the signal, and we have this delay to wash out the signal even more, and this SP, the screaming filter, with the input patch to the high pass input to get rid of the low frequencies so it does not clash too much with the bass line. Maybe we can try the bandpass input. No, it's too muffled. High pass input was fine. Okay, one last time. Save this patch. Now get rid of it. Awesome. So let's do another patch. Let's go 20 minutes from now. Let's pull in some oscillators. I really like this peak EQ. And I think the feedback folder should get another chance to shine. Let's pull in a Euclidean sequencer, another envelope generator, because we need some movement. Not yet the delay. But we will probably need an attenuator and an amplifier. Okay, let's get patching speedrun mode. We will use our 8th note pulse to trigger this Euclidean sequencer. I'll patch that into a trigger input. We will use this slower 4/1 clock to re-trigger the Euclidean sequencer. Maybe we can resync. Let's get a more standard pattern going. And if we choose a different speed for the LFO that modulates the hi-hat, we get a very different rhythmic feel in the whole beat. Okay, that is too broken. Okay, let's choose this basic two-step pattern and not waste any more time on the drums. Okay, before I zoom in on this new bassline patch, let's connect the amplifier real quick to the mixer. Okay. Let's choose some random Euclidean measures, like 5/14. Euclidean sequencer, basically what it does, it distributes 5 pulses over 14 triggers in a equal distance. As best as it can, of course. So since 14 is not divisible by 5 without a remainder, it gets more interesting. Let's put it this way. We use that in the gate input, turn down the attack, Since this is a gate input and we feed it triggers, we rely on the release stage. And when we link the release and the decay, we can control this with this one single knob. Also, we can disable the sustain, because without a gate signal, we will not get sustain anyway. And I turned this envelope into an AED envelope again. Well, in that case, only a decay envelope, because if I turn up the attack, since it expects a gate and not a trigger, it will only rise to the level after one sample trigger that the gate gives us, and with, let's say, 5 milliseconds, that's basically nothing. So I have to leave the attack at the minimum at 0. And only the decay is working now, which is perfect for percussive sounds. That's what we're trying to do now. So this oscillator into this peak equalizer, into the feedback filter, into the screaming filter, into this amplifier. Gives us this static tone. Okay, I like this. Let's add another resonance. This one is cool. Oh, some farty sounds. Nice. Awesome. This is pretty static. I mean, we can nice trick here. If you patch the same cable twice, you get double the CV. Let's choose a different. That works surprisingly well. Let's reset. Check if it still works. Oh, awesome. Okay, but we need some more movement. That is a very boring bass line so far. And the easiest way to add movement is to add an LFO. And that's exactly why we have the sine LFO. I like that module a lot. It gives you so much modulation options in such a small form factor, it's amazing. We'll set the first sine wave to some moderate tempo, let's say 1.1 Hertz. And this will be used to modulate the timbre, why not? Oh, we don't even need the attenuator because we have a dedicated attenuator here. Oh, that's awesome. Can also modulate the distortion. Okay, it's getting really cool. We use the combined output into this attenuator and into the filter. Okay, that's cool. Let's use the envelope again. Hi Gus, thanks for joining. Can't chat. No worries, all good. I'll be keeping an eye on the chat. Anybody wants to interact. But it's mostly just casual patching. Today we're in the drum and bass realm, and I've set a timer so we have 20-minute patches, and in 20 minutes we get some patch going. So today it's basically some drums, a bass line, and some other thing. more than 3 voices. It's a bit difficult for me in 20 minutes to get more than that, but we'll try our best. Okay, we got this bass line that's already very nasty. Let's see if we can get more notes. I'm losing words today. Some more tones going. Just realized this is all a single oscillator. Wow. Okay, let's go quantize this. Okay, awesome. I have no clue what scale this might be. As long as it sounds good, who am I to judge? Okay, maybe we can turn that one down a bit. Okay, I like that. What do we do? What do we do? Do we do atmosphere or melody? Let's do a cool melody. Something that comes in at the beginning of the bar and then washes out with some serious delay or something. That could be cool. Nah, we will not use envelope generator this time. We will use the AD envelope. I already missed it. I have used the other envelope generator now, but I like this one the most. Let's use this. Ah, bit crusher, why not? High quality bit crusher. It's actually funny because usually if you do sample rate reduction, you're limited by the actual sample rate of your host, and with Voltage Modular that's 48 kilohertz by default. So all you can do is a maximum basically of 12 kilohertz sample rate, because anything above that, oh no, not 12 kilohertz, I'm wrong. All you can do is 24 kilohertz. Anything above that will just not work. And with Bit Crusher, I actually also limited to 24 kilohertz. But this decimator, this sample rate reducer is oversampled, which doesn't make much sense. But it allows you to get to higher sample rates. Like here we're limited to 24 kilohertz, but we can use this CV input, which is exponential CV if I remember correctly, to get higher sample rates. And it works more like an actual ADC in this case, because we have the anti-aliasing filters and the anti-imaging filters. The anti-aliasing filter is before everything, so before the sample rate gets reduced and the bits get reduced, and the anti-imaging filter is afterwards. So these are two extra tools to sculpt your sound, and everything has jitter, and you can also add noise, which it's not dithering noise, but it's somewhat similar. Okay, I'm wasting a lot of time explaining stuff. We only have 8 minutes left. Let's get something going. I need more modules. I need a multiplexer, and I need let's do a step sequencer, why not? Okay. An oscillator, of course. This oscillator will be fed by the step sequencer. You know what? Let's actually delete that step sequencer and take this step sequencer, so we are sure that the notes are the same, because I have no clue what the scale is, and I have so little time left that I am not confident that I can tune it by ear in that little time. Let's create some pattern here. That's awesome. And we will add that into the multiplexer here. Let's create something else here. And that will go here. Okay. Now we need to connect some clocks. Trigger, 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 trigger. We will create the 3-trigger clock here. And we need to, I think I forgot to add the button to this sequencer and to this Euclidean sequencer. Shame on me. Oh yeah, I forgot. I need to reset our trusty sine LFO as well. Awesome. We need an amplifier. Let's put all of that here. Let's go with a second oscillator. Then we will connect the multiplexer output to the trigger input of the AD envelope. And this will go to the first amplifier channel and the second amplifier channel. And now we have 2 oscillator setups, so we already know it's going to be an FM patch. First oscillator modulator, phase modulates the second oscillator carrier. Then we'll go into delay and bit crusher, and from bit crusher right into here. Okay, we'll turn this okay, that's awesome. Add some more noise. Okay, that's cool. Let's reset. And we have 4.5 minutes left. I'd say let's shoot for the stars and try to get some atmosphere, some pad sound. We already have a lot of the building blocks here. We'll use another bit crusher, because I kinda like that right now. Back here. Let's go for a sample and hold thingy here. That will be clocked by another clock, and this clock will be half notes. Need to resync. And that will sample the bassline melody. Let's feed that into the oscillator, into the feedback folder, and the bit crusher, into the delay, into the bit crusher. And the delay will be endless. Okay, let's do this. Okay, sorry, that was annoying. Okay, we should use an envelope, in fact, here. And in this case, I really want to use it as an ADSR. So I will need a trigger to gate module, and our trusty TTG trigger to gate provides that functionality just right. I will need an amplifier for that, and now I'm running out of space. So let's move this down in the cabinet so we can zoom back in. Yeah, right. Okay, we have to zoom back out because I need this clock for the trigger to gate. What's cool about this trigger to gate, it has a sync feature, so we can sync length, and we will use 3/8, gate, decay link off, sustain. We have a minute left to polish everything. I'd say let's gain stage a little. Yes, it's kind of nice lo-fi. Let's adjust the drum mix a little. Okay. Okay, let's check. Did I forget anything? 10 more seconds. I will take this random attenuator and apply that here. Get some more movement in the pad. Okay, that was a bit stressful in the end because we have so much to add, but we did it in time. We have drums. Okay, I cheated. The drums were already there. But we have a nasty bass line, we have some, I wouldn't call it melody, some nice stabby things, and we have some background atmosphere. Okay, let's go over it one last time, then we move on, and let's do one more patch after that. Alright. Drums, very basic. Step sequencer kick, step sequencer snare. 2 step sequences into a multiplexer in an alternating pattern into the hi-hat. And the hi-hat groove is accentuated by this LFO. Without it, just sounds too static. But with it, drums instant groove. It's a really nice technique, that's why the hi-hat module has this CV input for the level control. Like if you compare that, the kick and the snare, they have these pitch inputs. So for the kick, obviously, so that you can make these nice 808 slides and stuff. And for the snare, because pitch snares sound awesome. But for the hi-hat, level is the most important control, so that's why CV is here. All of that into the submixer. The submixer is clipping, and then it feeds into our final output mixer. Turn everything down so that we can hear this nasty bass line. Gets sequenced by this Euclidean sequencer, and now the cables get in the way because that's a densely populated patch. I chose this ratio by random, so if you choose anything else, that should be fine as well. You can actually get Euclidean sequences to sound less random if you retrigger them within certain measures. In that case, we retrigger the Euclidean sequence after 4 bars. The Euclidean sequence then clocks this envelope, which is set to AD mode, or in fact no decay mode, because here I can show again, if I add attack, the signal cannot rise fast enough to some level to decay from. But yeah, so that's that. The sound is just one single oscillator into a peak equalizer that picks out some interesting resonances. Oh, you can actually find some more interesting resonances. Let's use an LFO to modulate that. Could be interesting, maybe. Also the second one. Okay, now it got wowly. Awesome, I like that. Okay, the peak equalizer feeds into the feedback folder. That's basically a wave folder with internal feedback that creates some gnarly tones. Then it's sent to the screaming filter, which is a highly nonlinear filter, has tons of distortion built into it. And it's an input mixing filter. We have high pass, band pass, low pass input. In that case, we use the low pass input. Band pass input sounds awesome as well. Maybe we can combine these. Awesome. I like this band pass input. Awesome. The filter frequency gets modulated by the envelope and by the combined sine waves here, an interesting pattern to generate this weird, jumpy, semi-random pattern. And then we have a standard amplifier that takes care of the volume envelope of the whole sound by applying this envelope generator here. We added this nice stabby melody thingy that introduces each new bar. It's just two oscillators in a modulator carrier configuration. So this oscillator is fed through an amplifier and then into the phase modulation input of the second oscillator. The amplifier makes it so that we can add some rhythmic interest, some dynamic interest to the modulation itself. We use this AD envelope to turn up, to modulate the modulation. Sorry, I'm really lacking words now. Okay, and the carrier oscillator is also fed onto the amplifier just to give it some dynamics. From here we go into a delay, into a bit crusher that makes it a bit more gnarly, and the delay is very nice to fill out the spaces because it only plays at the start and very end of each bar. Together with the drums, sounds quite nice. Since we all had time, we added some atmospheric background. Atmospheric background is just one oscillator routed via an amplifier into the feedback folder, into a delay, into a bit crusher. With a slower envelope, it samples the bassline notes in a slower interval, with a slower clock, so that we're in pitch, because we chose this sequence at random. I think basically when you pull in the CV sequencer, it gives you a random pattern, and I think we just used that pattern here. Maybe I adjusted it a little, I can't remember, but whatever, that's that patch. It's a little bit more going on in this patch, but I hope it was still easy to follow. Save one last time. And let's do one last patch for today. Get rid of everything and start your timer. Alright, okay. What do we do? Let's do something interesting. We have this noise, let's go with a modal bandpass. And frequency shifter, hey, whatever, what gives? Delay, and I need an AD envelope for this to work. And I will use a step sequencer because you used Euclidean sequence and counter already so much. Let's go with some more traditional sequencing. We will use our 8th clock and we will only retrigger with this button. Okay. In this configuration, I want to do some physical modeling. And for that, I need a highly resonant filter. The modal bandpass is highly tailored towards modal synthesis, so physical modeling. And we need something to excite the highly resonant filter, and in that case it's our noise, and that is the exciter. That gets shaped by this very short AD envelope. Let's turn down the level and go into here, and let's connect that. Let's pull in an amplifier, connect the amplifier to a channel in our mixer. And just so you can hear what's going on, okay, that's turned on. Okay. Awesome. We need some means to set a melody, so let's use the sample and hold. Why not? Let's get sine LFO going. And we need an attenuator to scale our signal a fair bit. Alright, the sample and hold will be triggered by our step sequencer. It will receive signal from this combined output of the sine LFOs. Let's set it to free running, set some different speeds. Awesome, let's offset the phases a little. And we will connect this retrigger here to the 4/1, so we get some more of a coherent pattern. Okay, that sounds promising. Let's open up the decay of our envelope to get more noise. Maybe we can even add a little bit of bias to the level, so we get this constant shimmery sound here. Okay. We use the second channel of the noise and a second modal bandpass filter to get another resonance. And of course we need to connect it to the same pitch information. Let's do a third one. So basically this is somewhat additive synthesis. We're adding partials. Okay, it sounds a bit like a horror movie right now. But it will, in the end it will work out. I'm confident that it will work out. We disconnect our amplifier from the output mixer for now. Oh, I even forgot to add the noise to the last one here. Let's listen real quick how that sounds. Oh. Okay, whatever, we go into the frequency shifter, and from the frequency shifter into the delay, and from the delay into the output. Okay, now let's get shifting. Maybe we can even use an attenuator and the delay output into an attenuator channel, turn it down and feed that back into the shifter input. Okay. Okay, we need to shape the signal a little more. I like this feedback patch, but it's a little much, especially in the high end. So we will add a ladder filter. Shave off some of the high hand from getting feedback. We can also use the ladder filter in the end to shape the sound more. Where is our AD envelope? Here we go. Okay, since we added the filter after the delay is no longer delaying in the general sense, but it's adding to the sound. Where's the AD envelope? Here we go. Okay, that's a cool sound. And I only wasted half of our patching time for this. let's do something more simple for the rest. Let's get the 1 oscillator, 2 oscillator, and let's I want to get another peak EQ. Where is it? Peak EQ here. That will be good. Let's get a clipper. Alright. And if you're paying attention, you already know I'm going for a respace again. This time a classic respace. We'll just use 2 oscillators, slightly detuned, into this clipper. Amplifier here, take a clipper output there, and then go into a mixer channel so we can actually hear it. Okay, that's already awesome. Respace. One of my favorite sounds. Okay, I want to sample this bass line so we can use that as pitch information for our oscillators. I then need to tune these both to the same attenuation signals, because otherwise it doesn't work. Like, we use the same signal but we scale it differently, so it will land on different notes. The offset is okay because it's a 2-octave offset. It will still be the same semitones. Okay, we will use this and use 4th notes to trigger that. Reset real quick. Okay, awesome. Get a sine LFO going to modulate the low pass filter. We need an attenuator again. Where are my sines? Here are my sines. Awesome. Going into the frequency shifter we can use. All right. We have this weird belly sounding physical modeling thingy. And we have this nice respace that's chugging along. There is not even a volume envelope or something applied to it. Just modulated by this sine LFO that we still need to re-trigger. And of course, let's connect our button to this sine LFO and this sine LFO. And did I forget some sine LFO? Nope. Awesome. Maybe we can even add some noise to the respace to give it some more presence in the high end. We will add some noise before the clipper so that it gets distorted heavily. We will high pass the noise and low pass it. We reduce the density so we get more of a velvet noise kind of type. Okay, that's nice. Now we have another layer of expression with the noise, because when the noise gets faded in by the LFO and the bassline and the noise gets crushed into the clipper, it almost feels like the bassline is breaking apart, and I really like that. We could try to go into the filter instead. Yeah, that works. Clipper is better. Maybe both. Okay, 3 minutes left. What do we do? What do we do? What do we do? We could go for some 6 stabby sound, AD envelope, just 3 oscillators, amplifier, and we will use diffuser, where is it? Diffuse. All of those into a clipper, the clipper goes into amplifier, amplifier out goes into diffusion input, that goes into our mixer. And we already have sound. Awesome. High pass, up the modulation, up the feedback. Okay, I like it already. Let's use that. Decay can go up to 8 seconds, that's a lot, but we will choose something like this. Let's use this 4/1. Why is it this silent? Oh, yeah. It's this silent because I'm not that smart right now. The mixer channel is turned down. Let's add some attack to this. Okay, that's thick. And we have like half a minute left, but I don't think I can achieve anything in that half a minute. So let's fine-tune stuff here, maybe. Some more feedback here. It might be a bad idea to add resonances here because we have a feedback loop inside of this delay, an external feedback loop between this delay, the frequency shifter, and the frequency shifter also has an internal feedback loop, so yeah, maybe not. It would have been cool if we had some node sequencer for this DnB thing. But since all of our node generators or melody generators get reset by this LFO, this clock, which triggers the AD envelope of this DnB thing, it wouldn't work. It would need its own dedicated tone generator, CV generator, and then I doubt we would be in key with the rest. I have to admit, I kinda like that patch now. In the beginning I was not sure where we are going, because this physical modeling stuff that sounded like a horror movie, but not like something pleasant, more like something unpleasant, very unpleasant. But with the bass line and the stab thing together, it kind of pulls that stuff together. Now I kind of like that. Also the low pass filter after the delay, it's just kind of interesting. Okay, I want to do one more thing for the snare, because I like that patch and now I'm fixed. Want to give it some variation, because I feel like there's not much going on in this whole track from melody and bassline perspective. And the drums are pretty monotonic as well. Okay. So every fourth bar, the snare makes a little variation. Maybe like this? Yeah, that's cool. I like that. Alright, let's save this one. Go over the patch one last time. And then I think we call it a day. We have this rhythm section. It did not change for the whole stream. Because setting up drums, it's always... it takes a lot of time and it's boring to watch. I understand that. So I set up these drums prior, and we will use these drums for every patch. I could have switched things around a little bit. Of course I think of that at the end of the stream. Classic. And never mind, we switched up the hi-hat a fair bit during the stream, so that's okay. Alright, step sequencer kick, that's pretty standard. Step sequencer is triggered by the clock and sequences the kick. For the snare we just mix it up a little. We have two step sequences and a multiplexer, which sequences the sequencer. So a sequencer, so to speak. It's just so that we get a little bit of variation at every fourth bar. Same goes for the hi-hat. Here, the hi-hat has two step sequencers that are also fed into a multiplexer. In this case it's an alternating pattern, so we turn this 8-step sequencer into a 16-step sequencer. And the hi-hat has the special thing applied to it that it has an LFO modulating its level, which adds some rhythm to the whole drum beat. If it's just a beating staticky hi-hat, it feels static, obviously, but if you apply some modulation, kind of comes to life. This LFO, the key part, is reset, or is not reset. Oh, forgot to patch that. Well, whatever, let's see what the frequency is, 3/8, so yeah, it catches up with the rest of the realm. It sounds cool, that's what counts. Let's go down here. We have our physically modeling patch using modal bandpass filter. Modal bandpass filter is in essence a very high resonant bandpass filter that rings out. You can set the ring with the dampening. If you turn the dampening down, it rings out more. If you pull it up, it rings out less. It's kind of hard to show now because we have 3 modal bandpass filters. Kind of like additive synthesis. We add partials because a resonating filter outputs a sine wave basically. And we can stack those in different ratios. That's why we have ratio coarse and ratio fine to do the same thing like additive synthesis does. We stack these sine waves, stack these partials to generate a more interesting tone. This tone is fed into an amplifier, directly from the amplifier we go into a frequency shifter that is mixed in to get more interesting tone. It then goes into a delay that adds some rhythmic interest. From the delay we go into a low pass filter that is sequenced, that is modulated by an AD envelope, which is pretty interesting in my opinion, because usually you have a delay at the end of a signal chain, so you can have the delays ring out, the feedback feeds back and kind of prolongs the sound. But if you apply further processing that limits the dynamic range, like an amplifier or a filter, you apply that to the feedback, to the ringing out as well. Oh, we have a comment by Work 24-hour stream when yeah, my brain is fried and I've been streaming for how long? I think it's been 2 hours now. So if 2 hours do that to me, I don't think I would survive 24 hours. But yeah, nice try. Maybe in the future we can do longer streams. I don't know yet. Let's go back to the patch. So we've been discussing this filter that muffles the delay. And the delay also feeds back into another low pass filter that goes through an attenuator back into the frequency shifter. So we have a feedback path here that feeds back the delayed signal and already frequency shifted signal to the frequency shifter to be frequency shifted and delayed again. Just create some interesting tones. We have to be careful though because of the resonances, and you kind of hear that it is ringing out every now and then. That's why we added the low pass filter. Okay, whatever. We have this respace playing. That's basically just 2 oscillators that are slightly detuned. I chose to detune this one up and leave this at that space pitch. These are fed into the peak equalizer, and the peak equalizer is not used actually. I forgot to turn up the gain. Ah well. Let's do this now. So we can use that to pull out some frequencies that might sound interesting with it, without it. It's kind of hard to hear in this whole patch, but it gives some more interesting character. This signal goes into a low pass filter and then into a clipper. low pass filter is modulated by some sine LFO combination that is attenuated. Yeah, only that. We drive the low pass filter, it's a nonlinear filter, to add some harmonics. And then we go into the clipper. And the input to the clipper is mixed with some noise that is also modulated by a sine LFO, which gives us this breaking up effect of the bass line every now and then. I kinda like that, when you drive some signal into a distortion and add noise. The noise is pushed away when you drive the clipper hard, so it is only present in the phases of the waveform that are not at the top and bottom but in the middle. Sometimes a very interesting effect, but it depends. We go to an amplifier. We basically only use as a mixer because we do not apply any modulation, but whatever. And we have this stab sound that kind of gives some bit of atmosphere at the end. We use an AD envelope and 3 detuned oscillators. One is tuned down, one is tuned up a little. We clip the signal. We feed it through an amplifier that is modulated by a very long AD envelope. That's 1.5 seconds decay, and yeah, well, 200 millisecond attack is not that much, but what gives. And this signal is fed in the diffuser, which is half of a reverb. Just adds some washes out the sound, heavily modulated. That's that patch. This time actually I won't save it again because I think I made the physical modeling sound worse somehow by explaining it. Yeah, that's that. Alrighty mighty, that's the end of the stream. We did, I think, 4 or 5 patches. I really enjoyed this time. Thanks everybody for joining. Thanks for watching. I hope you learned a thing or two. I hope I could show you the micro modules, the amazing micro modules. They are very versatile. We're really proud of these modules. Basically all you need to do some amazing patches. And since they are so small form factor, you have a lot of screen real estate you can use for other things or use to cram in more micro modules. Like this is a drum track, one melody, one bass line and some atmosphere, and it's not even half of my screen filled. I think that's amazing, but obviously I'm biased as the developer here, one of the developers. Okay, that being said, I hope you enjoy the rest of your day. Again, thanks for joining. Leave a like, please subscribe, and I hope you tune into the next stream as well. See you around. Bye.